Okay, so we've gone through two examples now. One of the examples we showed you one way by graphing by table of values. The other way I showed you was graphing using intercepts. The way that we talked about it in business class and that you saw me doing in con was using, let's say by slope or by standard equation of a line. Okay, so let's show you that for now. So we have 30n plus 10r is equal to 150. Okay, so this was our original equation. In this case, we're graphing r as y and n as x. So I'm just going to sub in those values just so that we're consistent with what you guys have seen before. Okay, the only thing I did was change the r and the n for x and y. Okay, just so it's consistent. So the way that I told you before, and I showed you a method to do it before on con, is y equals mx plus b. That's our standard equation for a line, for any straight line. So we want to rearrange this formula to look like this. So in order to do that, we need to isolate the y variable. So we need to move this 30x over to the other side, right? So we end up with 10y is equal to 150 minus 30x. Okay. Next, we want to divide each term by 10. The reason why is that allows us to isolate the y on its own. So we have y is equal to 150 divided by 10 is 15 minus 3x. Okay, now if I just rearrange this, I put the slope value first, it looks like this. Okay? So now that I have it in the standard equation for a line, y equals mx plus b, I know the slope is what in this particular case? Jacob? What's the slope of this line?
3x.
Sorry?
3x.
Yeah, not 3x. Remember, the slope is just the value of m, so it's the value in front of x.
3.
Not 3. What's in front?
Negative.
Right, negative 3. So my slope in this particular case, m is equal to negative 3. And what's my y-intercept, Jacob?
15.
Good, positive 15. Okay, so if we look at our graph now, we should notice that we get the same graph, right? So we're going to look at our y-intercept is 15. Sure enough, it's 15 right there. Same thing over here when we graphed it using intercepts. Y was 15. Okay, and then our slope is negative 3. What that means is for every 1 we go over, we go down 3. Okay, so rise is negative 3, so we're going down 3, so 15, 14, 13, 12, and over 1, we're running 1. Remember, a slope of negative 3 is rise over run, which is negative 3 over 1. So we're moving down every time, down 3 every time we run 1. Okay, so do you guys see how it's the exact same line? Everyone understand that? So there's 3 methods I've taught you now how to graph a straight line. Table of values, intercepts, and standard equation for a line. Okay, we'll do one more here for example 2. If we rearrange this equation now, we can rearrange it in this format. Alright, so I'm going to do that quickly. I have 3 fours y's is equal to, sorry, this was all equal to, I erased part of this. This is equal to 21, right? So I'm going to show that quickly. I'm going to rearrange this for y by itself on the left-hand side. Let's erase this for now. Okay, so we have 3, 4, y is equal to, I'm going to move this x over to the other side to isolate y. So I have 21 minus 2x. Okay, now to get y by itself, I need to multiply everything by the reciprocal of this. Okay, so I'm going to multiply everything by 4 over 3. And what that allows me to do is these cross out. So I just have y on the left-hand side. Okay, but I need to multiply each term here by 4 over 3. Any questions there? What I'm doing? Everyone's confused with that? Okay, so y equals 4 times 21 is 84. Still divided by 3. Remember, because a fraction times a whole number, it's 21 over 1. So multiplying the numerators is 84, multiplying the denominators is 3. Same thing over here. So negative 2 times 4 is 8 over 3x. Okay? 84 divided by 3 is 28. So we get y is equal to 28 minus 8 over 3x. I'm going to rearrange that to the format we like, where we're x values first, minus 8 over 3x plus 28. So there's my equation for the line. We're going to verify that. Let's see if it's the same. My y-intercept is 28. Yep, sure enough, my y-intercept is 28. My slope is negative 8 over 3. So what does that mean, Kevin?
8 to negative 8 rise over 3 run.
Good, negative 8 rise. So in other words, we're lowering 8 values, 1, 2, 3, 4, 5, 6, 7, 8, and we're running 3, 1, 2, 3. Okay, so we get that same line. Okay, take my word for it. The graph might not be that accurate, because there's not 28 ticks here, but the line would be identical if it was graphed exactly. Okay, any questions there? So again, 3 ways: table of values, intercepts, standard equation of a line. Okay, you can use whichever one you want on the test. I don't care in the quiz. All right, unless I specifically say use a table, and you have to use a table. Use something else, you'll get it wrong. Matthew.
Is this going to be on the quiz?
No. The quiz is only till 3.3. This is 3.4. All right, example 3. It says complete the table of values for 3x plus 2y minus 12. So what am I going to do here? Michael, right there. What am I going to do? It says complete this table of values. What do I do? How do I find this y value? It's not a trick question. I gotta do something with this x. What am I gonna do to find out what this y is? I might go behind him.
You have to multiply 3x by 0.
Yeah. No, I sub in, not multiply
Oh, sorry.
3x. But yeah, I'm gonna sub in 0 for x, right? Okay. Okay, see this? So my first value here then would be 3 times 0 plus 2y minus 12 is equal to 0. Now what do I do, Michael? Keep going.
Then you have to try to, well, the 3 times 0 cancels out.
Good.
And then you have to get the 12 to the other side.
Good.
So it's plus 12.
Good. Yep.
And then you divide the 12 by 2.
Excellent.
And that cancels out that 2.
Good.
And so y equals 6.
Excellent. Follow that, Michael? Yes? Okay, Marnier, next one. What do I do with this? How do I find this y value?
So first you have to do 3 times 1.
Good.
3. And then you bring.
Now what?
You bring the 12 over on the other side.
Okay. Leaving the 3 over here still?
Yes.
Okay. Okay, now what? Not so easy when Mr. Mills doesn't do it all for you. Jacob, what do I do next? Come on, guys. Noah, what do I do next?
Move the 3 to the other side.
Good.
And it's negative 3 now.
Yeah. Okay, keep going.
And then divide them all by 2.
Okay, good. Okay, Marnier, okay? Following that? No? I want to move closer too. You want to move it to Jesse's seat temporarily? Philippe?
Sorry, can you like minus 12 minus 3
Yeah,
and then do 9 over
yes. Yeah, you would have wanted to combine these first, right? Simply. Okay, last one. Kevin. How do I find out why?
You sub 2 correct?
Yeah, then what?
Then you move the 12 to the opposite side.
Okay, I think Philippe just told us a better idea before we move it. What can we do?
You do the 3 times 2,
Yeah, so we have 6 minus 12. What's that?
negative 6.
Right, so we have 2y minus 6 equals 0. Now what?
You can put the negative 6 on the other side. To the positive 6. And then you put the 2 on the other side, so 1 6 divided by 2.
So y is 3. Everyone okay with that?
Yeah.
Guys, this algebra is very simple. If you're having trouble with this, then you have to practice and ask me, okay? And come seek extra help, because as you can tell, I'm almost past this now, right? Like I'm taking a step back to slow this down, but this is supposed to be assumed that you guys know how to do this at this point. Hey, Philippe,
Sir, that's like, can we just use that way to answer the first question?
can you what?
Can we use that method to answer the first question?
You can do that, yeah, table of values, but you need to understand how to use the other methods as well. All right? And some of the other methods are easier, right? So now we can graph this, right? We have 3 points. So we have x is 0, y is 6, 1, 2, 3, 4, 5, 6. There's 1 point. X is 1, y is 4.5. So 1, 2, 3, 1, 1, 2, 3, 4.5. And x is 2, y is 3. 1, 2, 1, 2, 3. Okay, so there's our line. Okay? Any questions there? No? So this is really what we were doing in Con a couple days ago. So you should be able to tackle any problem that's a straight line now. However they give it to us. Whether they give it to us like this, or whether they give it to us like this, any way it should be comparable. Okay? Last example. Example number 4. Somebody want to read 168? Nobody wants to read. Oh, Selva, thank you.
Mia is traveling to a campsite 52 kilometers away. She plans to bike part of the way and canoe the rest of the way. She can bike at 30 kilometers per hour and paddle her canoe downstream at 8 kilometers per hour. Determine 3 combinations of biking and canoeing distances we can use.
So she can bike at 13, and she can canoe at 8 kilometers per hour, and our total distance is equal to 52. Okay, so our equation then would be 13 times whatever distance she bikes, plus 8 times whatever distance she canoes, is equal to 52. Okay, any questions there? That's our equation, right? Because we know that she's going to bike a certain amount of distance and canoe a certain amount of distance, and these two values times however much time she does either activity has to equal 52 as a total distance. All right, so determine 3 combinations but biking and canoeing distances Mia can use. Alright, so all it's asking for here basically is a table of values with 3 values, B and C, where we choose 3 values and we find out the corresponding 3 values of C. Alright, so the easiest one we could say is that she doesn't bike any distance, she's only going to canoe. Then she decides to bike for 1 hour and say 2 hours. So these will give us 3 combinations. So what do I do with these values now? Yeah, good.
You sub them into the equation.
Right, I sub them in. So 13 times 0 is 0. 8c is equal to 52. So c is equal to, what's 52 divided by 8? Anybody? Yeah? 6.5. Thank you. Okay, next one we're going to sub in 1. So we have 13 times 1 plus 8c is equal to 52. So we have 52 minus 13 is 39, I believe. It's 39 divided by 8.
So why you minus 13? Should it,
Joseph,
It's 4.875.
4.875. And last one, 13 times 2 plus 8c is equal to 52. 8c is equal to 52 minus 26 is 26. C, 26 divided by 8. Joseph?
3.25.
3.25. So, not the neatest numbers, but nonetheless, here are our combinations of biking and cycling that she can take. So if she decided not to bike at all, she needs to canoe for 6.5 hours. Okay, 6.5 times 8 is 52. Yep.
Could you use like switch around the order so C is where B is and
Yes,
C
you
is
could.
where B is?
Yeah, in this case you could. You could make C the independent variable and B the measurable or the dependent if you wanted. Okay? So I would conclude this by saying, I'd write, obviously this is a word problem, so there would be a sentence I would need to write, 3 combinations are, and then you would go over these 3 combinations. So biking for 0 hours, canoeing for 6.5 hours, biking for 1 hour, canoeing for 4.875 hours, biking for 2 hours, canoeing for 3.25 hours. Yep.
did you round the decimals?
In this case I wouldn't, because they're all terminating decimals, so I would leave them. Okay, and they're only 3 digits, so I would leave it. Yep.
And you can choose whichever variable you want to be the independent.
Yes, I think just asked that. Josh just asked that. Okay, so just in summary now, last part here. Okay, so linear relation. We can write in 3 different forms. AX Okay, so 3 different forms. Any of these type of forms, if you see an equation in either of these 3 forms, you should realize that it is a straight line. And you should also realize that there's 3 methods in which you can solve it or graph it. Okay, 1 is a table of values, 2 is intercepts method, and 3 is using slope method or rearranging into standard equation of the line form. Yeah.
Which one would you say would be the better one?
It depends on the question. Depends what they give you. If they gave me something like this, I would probably use intercepts. If they gave me this, I would use slope method. right? It just makes the algebra a little easier. So, again, 1, 2, 3, the table of values, intercepts, and slope. I would say table of values is probably the slowest, right? You have to draw this whole table and then plot 3 different dots. Intercepts might be the second fastest because you got to plot just 2 dots. And slope may arguably be the fastest. If you already have it like this, your y-intercept is right there, so you already have 1 point. You haven't done anything, you already have a point. And then m, you just follow whatever the slope is to find that second point. Okay, so I'd say arguably this is maybe your best choice. And this tends to be what we use only in grade 10. We don't go back to table of values or intercepts. We'll just use this. Okay, for straight line, simple enough. We know where the y-intercept is. We know what the slope is. We can draw the graph. Right? And that's what I was showing you in computer class, basically using that. Yeah?
So which examples that you did on the board is like the same one as the intercept one?
They're all the same. You can use the method for any of them. So the one example that was only intercept method originally was example 2, I believe, which is right here. Example 1 or example 2? I think I used it for example 1 and 2. Okay, but you can use either of the 3. Any questions? Mike?
For the intercept, you're just putting 0 as your variable, right?
Yes, that's right. 0 for x and then 0 for y. Any other questions? All right, that's the end of the lesson.